Thermodynamic Lecture 3 Thermal Expansion. Expansion means increase in size. Thermal expansion means increase in size on heating is called thermal expansion. There may be, if the substance is solid, then expansion will be expansion of solid. If it is liquid, expansion of liquid. If it is gases, expansion of gases. Expansion of solid. Three type of expansion takes place in solid. First, linear expansion. Linear expansion in a length of heating is called linear expansion. Increase in length. Increase in length L2 is equal to L1 1 plus alpha delta T alpha delta T, where L1 and L2 are initial and final length on heating. And delta T change in temperature. Coefficient of linear expansion alpha is equal to delta L by one into delta T, where L is equal to real length, delta L change in length, delta T change in time. Superficial expansion. Expansion in area. Expansion in area on heating is called superficial expansion. Then increase of area. increase in area A2 is equal to A1 plus 1 plus beta delta T, where A1 and A2 are initial and final area, and beta is the coefficient of superficial expansion. Beta is coefficient of superficial expansion. Beta is equal to delta A by A into delta T, where A area, delta A change of area, delta T change of time. Cubical expansion. Expansion in volume on heating is called cubical expansion. Increase in volume V2 is equal to V1 1 plus gamma delta T, where V1, V2 are initial and final volume. Gamma is coefficient of cubical expansion. Then gamma is equal to delta V by V into delta T, where V real volume, delta V change in volume, delta T change in temperature. Relation between coefficient of linear superficial cubical expansion beta is equal to 2 alpha, gamma is equal to 3 alpha, or alpha is to beta as to gamma is equal to 1 is to 2 is to 3. Expansion of liquid. In a liquid, only expansion in volume takes place on heating. The apparent expansion of liquid, where expansion of containing liquid heating is not taken account, then observed expansion is called apparent expansion liquid. Coefficient of apparent expansion of liquid is equal to apparent increase in volume by original volume into rise in temperature. Then real expansion of liquid. When expression of container containing liquid on heating is also taken into account, then observed expansion is called real expansion of liquid. Coefficient of real expansion of liquid equal to real increase in volume by original volume into rise in temperature. Anomalous expansion of water. When temperature of water increases from 0 degree centigrade, then its volume decreases up to 4 degree centigrade, becomes minimum at 4 degree centigrade, then increases. The behavior of water around 4 degree is called anomalous expansion of water. Expansion of gas. There are two types of coefficient of expansion of gases. Volume coefficient, volume coefficient gamma v, gamma v. Volume of coefficient gamma v at a constant pressure, the change in volume per unit volume per degree Celsius is called volume coefficient. Volume coefficient is equal to V2 minus V1 by V0 T2 minus T1. V0, V1, V2, volume of gases at 0 degree centigrade, T1 degree centigrade, and T2 degree centigrade. pressure coefficient. Denoted as a gamma p. At a constant volume, the change in pressure per unit pressure per degree Celsius is called pressure coefficient. Gamma p is equal to p2 minus p1 by p0 into t2 minus t1, where p0, p1, p2 are pressure of gas at 0 degree temperature, T1 degree temperature and a T2 degree temperature. Practical application of expansion. When rails are laid down on the ground, space is left between the end of two rails. The transmission cable are not tightly fixed to the poles. The iron rim to be put on a car wheel is always a slightly smaller diameter than that of wheel. A glass topper jammed in neck of a bottle can be taken out by warming the neck of the bottle. Due to increment in its time period, a pendulum clock becomes slow in summer and will lose time. Loss lost loss of time in this time delta t is equal to 1 by 2 alpha delta q t. At some higher temperature, scale will expand and the scale reading will be lesser than the true value. Then scale reading is 1 plus alpha delta t, where delta t is temperature difference. However, at a lower temperature, scale reading will be more and the true value will be less. The branch of physics deals with the study of transformation of heat energy into other energy, other form of energy, vice versa. A thermodynamic system is said to be a thermal equilibrium when microscopic variables like pressure, volume, temperature, mass, composition, its that characterize to the system do not change with the time. Thermodynamic chemical system. Thermodynamical system. A assembly of extremely large number of particles whose state can be expressed in terms of pressure, volume, temperature is called thermodynamic system. Then may be a open system. Open system, it exchange both energy and matter to surrounding. Means example, cup of tea, then it will is exposed to environment, then it will then the matter inside the coffee or tea will go outside, and heat energy will decrease by heat will be exchanged to the environment. This is the best example of open system. Closed system, it exchange both it exchange both energy and matter. But a closed system, it exchange energy, it exchange energy but does not matter. Example, pressure cooker. Then after heating this pressure cooker, then the matter will be constant, but if we keep sometimes, then temperature will be decreased. Means it exchange energy to the system but does not exchange matter to the system. So it is a closed system. Isolated system. It does not exchange energy. It does not exchange energy or matter to the surrounding. Best example is thermopacks. It neither exchange energy to the system, surrounding or matter, but it is after sometimes there is decrease of temperature. It is a partially isolated system. And what is system and what is surrounding? If we will take a cup of tea or coffee, then this is the system under study. And except cup of tea, the whatever may present outside, that is surrounding. This is the system and this is the surrounding. A thermodynamic system is not always in equilibrium. For example, a gas allowed to expand freely against vacuum. Similarly, mixture of petrol vapors in air, when it ignites by a spark, is not in equilibrium state. Equilibrium is acquired eventually with time. thermodynamic parameter. The state of thermodynamic system can be described by specifying pressure, volume, temperature, internal energy, and a number of mole. These are called thermodynamic parameter or coordinates or variables. Work done by thermodynamic system is given by work done by a thermodynamic system. W is equal to P delta V, where P is equal to pressure and delta V is equal to change in volume. Work done by thermodynamic system is equal to the area enclosed between the PV curve and the volume in axis. Work done by thermodynamic system depends not only upon the initial and final state of the system but also depends upon path followed. Work done by the thermodynamic system positive as volume increases, negative volume decreases. Internal energy denoted as U. Total energy possessed by any system due to molecular motion, molecular configuration is called internal energy. Internal energy of thermodynamic system depends upon temperature. It is a characteristic property of state of system. Zeroth law of thermodynamic. According to the law, two systems in isothermal equilibrium with a third system separately are in thermal equilibrium with each other. Thus, if A, B are separately in equilibrium with C, that means if Ta is equal to Tc and Tb is equal to Tc, then implies Th is equal to Tb. The system A and B are also in thermal equilibrium. First law of thermodynamics. Heat given to a thermodynamic system, delta Q, is partially utilized in doing work against the surrounding, and the remaining part increase internal energy of the system. Therefore, delta Q is equal to delta U plus delta W. The first law of thermodynamics is a restatement of principle conservation of energy is isothermal process change internal energy is equal to zero. Therefore, delta Q is equal to delta W. In a adiabatic process, no exchange of heat takes place. Therefore, delta U is equal to minus delta W. In a adiabatic process, gas expand its internal energy, hence temperature decreases, vice versa. In a isobaric process, work done is zero, delta W is zero. Therefore, delta Q is equal to delta U. Thermodynamic process. A thermodynamical process is said to be take place when some changes occur in the state of a dynamic thermodynamic system. Thermodynamic parameter of system change with time. Isothermal process. Isothermal process. A process taking place at a thermodynamic system at a constant temperature is called isothermal process. Isothermal process are very slow process. These process follow Boyle's law, according to which PV is equal to constant. PV is equal to constant. So du is equal to NCV dt. As dt is equal to 0, du is equal to 0, internal energy is constant. The first law of thermodynamics, dq is equal to dw. When heat given to a system equal to work done by this system surrounding. Work done W is equal to 2.3026 mu RT log 10 VF by VI is equal to 2.3026 mu RT log 10 PI by PF, where is equal to number of mole, R is equal to ideal gas constant, T is equal to absolute temperature. After differentiating PV is equal to constant, we get dP by dV is equal to minus P by V, and minus dP by dV is equal to P. Melting process is a isothermal change because temperature of substance remains constant during melting. Boiling process is also a isothermal operation. Then adiabatic process.